Hello and welcome to TC Vision Now How. Today we'll show real-time synchronization from Oracle 12c to a big data environment. We use an Oracle table with about 50,000 records and transfer change data via Kafka to a big data environment. The change data is transferred from an Oracle Linux to an Ubuntu Linux server. Here are the two components, the Oracle server on the left and the Kafka server on the right. We start with the table on Oracle. The data represents the inventory of an imaginary department store. The data types are both numeric and alphanumeric. Kafka is installed on an Ubuntu server. We start a consumer that writes the captured data to a file so we can have a look at it later. The processing chain contains a sender that sends captured change data to another server without further processing. It is processed by the receiver and written to the big data environment. Let's start with the creation of the metadata. First, we define the output target. All output targets writing to big data environments have the target type big data. The connection string indicates which protocol and transport layer are used. We accept the default values JSON and Kafka. These are the settings for JSON. We can modify the output. These are the settings for Kafka. We enter the address of the broker and the topic name. The output target is created and we can start importing the metadata. We want to create objects for input, output and replication. Our output target is the Kafka that we have just created. The data should be transferred from an Oracle database on our Oracle server. We check the net service name and the credentials that are used to access the Oracle log miner. The tree structure allows us to select the tables. Here we supply the name of our output table. It only contains the table name, because there are no schemas in Kafka. The import was successful and we can have a look at the results. We see the input, the output and the replication links between them. As first part of the processing, we create the sender. Processing tasks are created in so-called scripts. We enter name for the script. Our task should read Oracle log records using the Oracle log miner. We confirm the connection string to the database. Then we choose to do no processing and send the captured data to an agent on a remote server. We select the remote server and supply the name of the receiving script there. With a single click we can edit it here if it already exists. In our case it does not exist yet, so it is created. We can tell the script about the format of the data it will receive. The output should be completely processed and written to the target we defined in the metadata repository. It would also be possible to use restart files to prevent data loss if the replication process is disrupted. For our demonstration, it will not make a difference. Now we start the sender script. It will automatically start the receiver and begin communicating with it. We go back to the Oracle and display a row. The price of this item is $33.49. Let's modify it. To create some more change data, we also insert a new row. Double-clicking on any running script shows statistical data. Here we can see that 2 data records have been written to the target. We see one transaction with two changes. The first one is the record we updated. It contains our new price. The second entry is our insert. All data has been written to the consumer correctly. What did we just see? We saw that TC Vision can efficiently use the OCI interface to read change data from Oracle and send captured data to a remote server without further processing. The TC Vision architecture allows shifting CPU load to any involved server. This can also be a dedicated server in order to keep the workload away from the database servers. Different transport layers and protocols allow flexible adjustment to further processing in the big data environment. New protocols and layers can easily be added due to the flexible architecture of TC Vision. Thank you for your attention.